Last question. Questions 5A, B, C, and D. I'd like you to try it on your own first, if you get a chance to, and then we'll work through it together. So given that this, again, displacement equation talks about the position of a particle with relation to the origin, which is O, where time is greater than or equal to 0, it says find an expression for the velocity and the acceleration. So v of t is equal to 3t squared minus 3, and a of t is equal to 6t. It then says find the initial conditions and hence describe the motion at this instant. So the initial conditions are s at 0, v at 0, and a at 0. That means plug in 0 into the displacement, velocity, and acceleration and tell me what you get. Well, you get 1 centimeter, you get negative 3 centimeters per second, and you get 0 centimeters per second squared. This means that this object starts 1 centimeter to the right of the origin and is moving left at 3 centimeters per second, 3 centimeters per second with a constant velocity. Not too bad. We're pretty much using the information in the description words that are at the beginning of this note to describe what's happening to this particle. Next question, C, is asking what's happening at 2 seconds. Try it yourself, see if you can get it, and then verify that your answer is the same. Hopefully you've had time to try the question itself, and your answer should say 3 centimeters to the right of the origin, moving right at 9 centimeters per second, and accelerating at 12 centimeters per second squared. Last question of the day says, find the position of the particle when changes in direction occur. Well, we know changes in direction occur when something happens at velocity, i.e. the object is stationary. So I want to go back to my velocity equation, which is 3t squared minus 3. I want to set it equal to 0. I get 3t squared is equal to 3. T squared is equal to 1, so t is plus or minus 1. We know that t can only be positive because it's time, so t is equal to 1. Well, that's the time when the change in direction occurs. I want to know the position of the particle at this time. So I want to plug in s at 1, which is 1 cubed minus 3 times 1 plus 1, which is negative 3. So this object is 3 centimeters to the left of the origin when its change in direction occurs. I hope that note's been pretty clear. Homework is posted on Blackboard. Please make sure that you get it done, and I will see you again soon. Take care, everyone.